So now again you are not required to discount each cash flows to the present. Now we have valued this one to the end of year 5 or to the terminal year. So now if I ask to calculate the present value or the value here. So since we know the value of this investment to the end of year 5, so directly you can discount this value to the year. But if first time if I ask you to calculate the value of this investment today, again no option. Separately you have to discount each to the present. Right? Since you have valued this investment to the end of year 5, no need to discount each cash flows again to the present. Quickly, directly, you can take the future value. So future value is 252,172. So this is the end of year 5. This is end of year 5. So you have to discount this value by how many years? Back. You have discounted it back for how many years? 5. 1, 2, 3, 4, 5. So you have to discount it back for 5 years. So you are not, what is the discounting? So here you have to discount for 5 years. So this is the present value. Right? But for the initial, if I ask to calculate this value, no, wait. Separately you have to discount this to the present. This for 2 years, 15,000 for 3 years, 65,000 for 4 years. So likewise you have to discount. Then you get the total. So that is the value. So at the moment you can check that one also. So you are getting same answer. Because here future equivalent value. This is what future equivalent value after adjusting for the time and also for the risk. So this is future equivalent value. So we have valued it to the end of year 5. So now you can compound this value to any point. That is the way. So what is the present value? I think it is 156. 578. Okay? Did you get it? 156,578. Now we have future value or the value at the end of year 5, 252,172. And also we know the current or the present value of this investment. Considering all cash flows and assuming this 10% interest rate remains constant without changing. Now I am asking you, what is the value of this investment to the end of year 3? Again consider investment as total. Consider the whole cash flow. What is the value of this investment to the end of year 3? What is the value of this investment to the end of year 3? What is the value to the end of year 3? So here. What is the value? So you can use either present value or the future value. So if you are using here the present value, so in the timeline you have to go forward. So then you have to compound this value 1, 2, 3 for 3 times, 3 years. So then you can calculate 156,000, 578,000 compounding. The process is compounding. So 1.1 into the power 3. So you can get the value here. So if you are using this future equivalent value, so you have to come down. You have to come back in the timeline. So you have to discount 1, 2 times. So then if you discount this number 252, 172 for 2 times, so you get the answer. You get the same answer. Either you show present value or future value, the answer will be same. Checking both ways whether you are getting the same answer using present and as well as future value. What is that? 200? 208. Is the other 400? 406. Right? At the very beginning, if I ask you to value this investment to the end of year 3, suppose you have no future value, no present value, so you are not valuing this cash flow to either present or to the future. Initially, I am asking you to value this investment to the end of year 3. Considering total investment period. I am asking to value this investment to here. So then, what you have to do? You have to compound this cash flows to here. These cash flows you have to discount. So then again you will get the same answer. Right? Considering this end of year 1, so you have to compound this to get the value to the end of year 3, equivalent value. So this is end of year 5. So in order to get the present equivalent value to the end of year 3, you have to discount for 2 years. So again you will get same answer. You can check it at home. Right? You will check and understand. So this is the way of calculating present value, future value for multiple uneven cash flow. Right? So in case of the multiple uneven cash flow, you can see at a common point in time, you have to calculate sum of the future values of the individual cash flows at that point. So you have to consider individual cash flows. You have to either compound or discount to get the required value. I think that is easy, right? Because now you have learned the concept. Okay, any question? Right. So now we are going to the next type of cash flow. You can do this one at home, right? Nothing difficult. This is example for the this multiple uneven type cash flow. You can manage annuities. Right? Annuities. So what is the difference between multiple uneven cash flows and the annuities? What is the difference between that multiple uneven cash flow just now we discussed and the annuities? What is the difference? I think at the first year I define these cash flows. In the annuities, you are getting same amount, same even cash flow, and also the time, the gap or the time range also even. If it is yearly, all the cash flows should be yearly. If it is monthly, all should be monthly. If it is quarterly, so likewise. So that is the difference. You mentioned it clearly. Now, for the example, for the annuities, loan installment. After you are taking a loan, you are deposit the installment to the bank at the end of each month. So this installment is annuity. But this electricity bill, telephone bill, they are not annuities because they are different each month based on the consumption. So these are multiple uneven cash flow. Right, I think this is annuity. That in the practical work you can identify annuities. There are so many examples. Is a series of identical cash flows that are expected to occur each period for a specific number of periods. Identical cash flow. They are identical. That is the difference. So annuities can be different types. Here we have mentioned three, but in addition to that, perpetuity also there. Ordinary annuity, annuity due, and the deferred annuity. So what is the ordinary type annuity? Ordinary annuity means if cash flows occur end of the time period. Suppose this is the annuity 0, 1, 2, 3. So end of year 1 you will get 1000. End of year 2 you will get 1000. End of year 3 also you get 1000. So this is the annuity. So here cash flows occur end of the period. So this is end of year 1, end of year 2, end of year 3. So this is we call ordinary annuity. This is the default. This is the default case. This is ordinary type annuity. Now if you take the bank installment, it is ordinary annuity. Bank installment, suppose that if you take the bank loans today, your first installment is due 1 month from today. So that is the ordinary type annuity. So that transaction occurred today. That is 0. It's a transaction. So your first monthly installment occurred 1 month from today. So this is the ordinary type annuity. Right? So this is the first category, annuity with end of period cash flow. That is ordinary. So next one is the annuity due. Suppose this same annuity, if it is occurred like this, say 0, 1, 2, 3. Plus 1000 occurred beginning of year 1, beginning of year 2, beginning of year 3. This is we call annuity due because here cash flows occurred immediately at the beginning of the period. Year 1, beginning of year 1, beginning of year 2, beginning of year 3. So this is we call annuity due. So cash flows occurred beginning of the period. Can I have an example for this due type annuity in the practical one? Annuity due example. Yes. Leasing payment. Normally it is occurred at the beginning of the period. Down payment is a different. So in the leasing installment, first installment, if you are paying now suppose at the transaction date, so that is we call annuity due. Now if you take the rent, so normally the rent we are paying for the beginning of the period. If you are paying the 1st of January, so that is for the January month. So that is beginning of the period. So the rent can be annually due, and also some loans are there. This institution requiring first installment immediately. There are some conditions, some loans with that kind of conditions. අපි අද ලක්ෂයක් ගන්නවා එයාලා කියනවා පළවෙනි ඉන්ස්ටෝල්මන්ට් එක අදම ගෙවන්න ඕනේ කියලා. So then it is a due type annuity. First installment you are paying beginning of the period immediately. So then it is a due. So in the questions you can understand because we are providing some hints to identify whether it is due or ordinary. that is the difference. Are you clear the difference? Ordinary, due. Remember in the papers or in the questions, if it is not clearly mentioned whether it is ordinary or due, so you have to take it as a ordinary because it is the default, right? So if it is no any clear hints or the things are mentioned whether it is ordinary or due, so you have to take it as the ordinary type value, right? So this is ordinary, this is ordinary, this is default. Right. So then another one, deferred annuity. What is the deferred annuity? If annuity occurred with some delay, say suppose here 0, 1, 2, 3, 4, 5, 6, so likewise. So there is no any cash flow at the year 1 and year 2. There is a lag. So then cash flow occurred beginning end of year 3, say 1000, 1000, so likewise. There is no cash flows in the initial period. After certain delays, after the certain lag period, so you are getting some cash flow. Annuities that begins more than one period from today. So that is we call deferred type annuity. So this type of things can be happen when with the judgment, court judgment, says to pay some what you call maintenance charges or some compensation, employee compensation. So then there will be some grace period. After a certain period, you have to pay compensation, some charges. So this is the grace period. Right, so the first 2 periods there is no any cash flow, so that is occurred after the certain periods. So this type of things we call deferred type annuity. So again you can consider this as a ordinary type or the due type, and we can value. So we discussed that valuation of the deferred type annuity also. This is the any question? No. The other one, the last type of annuity is the perpetuity. It is there, right? Perpetuity. Perpetuity means it is an annuity for forever. It's an annuity, no end. Can I have an example for that? Annuity goes forever, for an indefinite period. Yes. Pension. That is the one example would be the pension payment is a type of perpetuity type annuity because we don't know it. So that is go for that uncertain, undefinite period. So that is the example for the perpetuity. So we discussed the perpetuity annuity, the perpetuity type cash flow valuation also. Right, so these are the types of annuities: ordinary, annuity due, deferred, and the perpetuity. So let's start with the ordinary annuity. Ordinary annuity. Now you can see example here. Assume you deposit 40,000 each at the end of every year. At the end of every year. So when it say at the end of every year, it says that this is the end of the period annuity. End of each year. Right? Without a question statement realize this is the ordinary. Because 40,000 occurred at the end of every year. So that is at the end of the period. For 20 years in a savings account that pays 12% per annum. 12% per annum. Annually. So how much will you have at the end of 10 years? How much will you have at the end of 10 years? So now this is not a single cash flow. This is not a multiple unlevered cash flow. This is an annuity, ordinary type annuity. So now you have to calculate, you are planning to deposit 40,000 at the end of every year for 20 years in a savings account which pay 12% per annum. So you want to know what is the account balance, what you have, how much would you have at the end of 10 years. What is the way? It's not possible compounding each cash flows to the 10 years. That is not manageable. For 20 years, you cannot compound each cash flows to the 20 years. It's not possible. So therefore, there is a formula to calculate the present value of this ordinary type annuity. So that is the formula. Future value of the, not the present, right? Future value of the ordinary annuity is equal cash flow. Cash flow means periodic payment. Future value of the ordinary annuity is equal cash flow, that is your periodic payment. Now in this example, your periodic payment is how much? 40,000. At the end of each year, you deposit 40,000. So that is the periodic payment into 1 plus r into the power n minus 1 divided by r. So this is we call future value interest factor for given r for given period. 1 plus r into the power n minus 1 divided by r. Right? This part we term as the future value interest factor annuity. Future value interest factor annuity. वार्षिक अनागत वटिनाकम पॉलिसाधक. Last day I think you remember I show you the two tables. Our tables dekak pennuwa. Ekak tama present value interest factor table, future value interest factor table. So third one is future value interest factor annuity table. This is the third table. I told you that there are 4 time value tables. Single cash cost. So the third table is here, future value interest factor for annuities. Either you can use table value or you can calculate this annuity factor using this formula. From the table you can extract without much trouble. But anyway, for the exam you are not given table, so you have to use this formula to get the annuity factor for the future value annuity cash. Right. So I will right now let's apply the formula first and we will calculate the value here. Apply this formula for this example. Now here you deposit 40,000. Right? Your cash flow is 40,000. You deposit 40,000 for 20 years. But you need to value this at the end of 10 years. You want to see the balance at the end of 10 years. Assuming this 12% interest rate per annum remain constant. ඒක වෙනස් වෙන්නේ නැහැ කියන assumption එකෙන් තමයි අපි මේ ගන්න. So therefore future value interest factor annuity is equal 1.112 into the power 10 minus 1 divided by 12. So this is the future value interest factor for annuity. 1.112 into the power 10 because n is 10 years. R is the interest rate of this deposits, savings account, 12% per annum. So at the end of 10 years, how much will be collected or what is the compounded value? What is the 2.8 million 82,097 eyes at the 20 years. How much the 10 years? You can calculate it. At the end of 10 years, 701, 949. So you will get this 700, 1,949 at the end of 10 years. So if you want to accumulate, if you have a financial goal to get this amount in 10 years, so you can have your personal plan to collect this money. So you have to deposit this much, right? Now suppose in this example, now this is at the end of 20 years. This one also you can check later. Suppose here, this 12% interest per annum, right? Suppose like this, here you deposit say 40,000 monthly. You need to know the monthly cash flow if you consider the more frequent compounding. Suppose here you deposit this 40,000 monthly, right? You deposit 40,000 monthly, so you can remember under the timeline assumption I told you, there is a norm, there is an assumption, cash flow frequency should be equal to the compounding frequency. අපි time value වල ගණන් හදනකොට ඒක given, right? So if you deposit 40,000 monthly, your cash flow frequency per year 12 times to 12 times. Suppose in this example, you deposit this 40,000 monthly in an account which pay 12% per annum compounded monthly. How much would you have at the end of 10 years? Only thing, now you deposit this 40,000 monthly at the end of each month in the account which pay 12% interest compounding monthly. 12% per annum compounding monthly. So how much is the balance at the end of 10 years? So you deposit 40,000 monthly. So you can remember for the single cash flow, we discussed more frequent compounding. So now here you deposit 40,000 monthly. In the account, this pay 12% per annum, but compounded monthly. So in this formula, you have to adjust slightly. When there is a more frequent compounding, I think you can remember here. Here, interest rate, you have to divide by n. When there is a more frequent compounding, interest rate you have to divide by m. N you have to multiply by n. What is them? What is them? We define it. M is compounding frequency per year. We defined under the last week under the single cash flow more frequent compounding. M is compounding frequency per year. Now in this case, compounding frequency, how much? Cash flow frequency is 12. So then compounding frequency also should 12. So that is 12. එතකොට මතක තියාගන්න අවුරුද්දක් තුල එකපාරකට වැඩි ප්‍රමාණයක් cash flow deposit වෙනවා නම් එතකොට ඒ නම් එකට අනුව අපිට compound කරන්න වෙනවා. In here, if you deposit 40,000 monthly, so you have to compound consist with that cash flow frequency. So then you can calculate value. Future value is equal. You deposit monthly 40,000, not annually, yeah? Monthly 40,000 into. So now you have to work out the annuity factor. R 12% per annum compounded monthly. So 12% divided by 12, monthly rate is 1%. Okay? 12 divided by 12, 1%. So then 1.01 into the power, n is 10 years, but frequency is 12, so it becomes 120 minus 1 divided by 0.01. If you deposit this 40,000 monthly, this is the amount you will get at the end of 10 years. So you can calculate it. If the factor is 230, we will get 230 as the relevant annual factor. It's into 40,000. So we get 9.2 million 547, something like that. Did you get this also? Right. So now let's go to the table. You have to familiarize that one also. So I told you 4 tables are there. 2 already covered. So this is not the, this is future value single cash flow. This is future value annuity. So this is the table. This is the relevant table. Future value for annuity. So in our example, our rate is 12%, same format, right? You can see in the column wise different rates and the row wise number of periods. So here our rate is 12%, right? This is the column. So time period, initially for the initial one we take the 10 years. So our annuity factor is 70.54. This is what you got by applying the formula also. Okay? 70.5487. So without trouble, you can take this one from the table. But anyway, sometimes for now, if you got this monthly deposit, the table factor you cannot trace because in 120, 1%, then negative up to 25. You can see some tables are there up to 100 like, but here you can see up to 25 n. But if you go monthly, n is 120. So then you can't trace the annuity factor from the table. So you have to work out using the formula. Right, I think this is the third table, future value interest factor for annuity. Right, so now if you go to this one, you can see in this slide, this is the extraction of the table factors. If you look at the last column, what you can see? Future value interest factor annuity for 12%, at 12% for 10 years. Some extraction from the table. If you look at the fourth column, it is future value interest factor, single cash flow. Look at the last two columns, right? The fourth one, future value interest factor for the single cash flow. The last column, future value interest factor for annuity. If you look at these two columns, what sort of relationship you can observe? If you look at the last two columns, is there any relationship between the single factor and the annuity factor? Yes? Cumulative number. If you look at here, this 4.77, this one, 4.77, it is the annuity factor at 12% for 4 years. So this 4.77 calculated by taking the cumulative value of the single cash flow. You are so correct. Good. If you look at here 17.54, if you take, this is the total of these single factors for 10 years. So you have some advantage of knowing this relationship. In any case, in your personal management or personal financial decision, in any case, if you forget this formula, there is a chance to forget that one, getting complicated. In case, if you forget it, you can calculate single factors quickly, get the total. So that is equal to the annuity factor. Single factor in the form with 1 plus r into the power n. Yeah, the single factor, future value interest factor. Future value interest factor is equal 1 plus r into the power n. So this is not really, you will forget it. So in case if you forget this annuity formula, annuity factor formula, you can work out quickly the single factors and get the sum. So that is equal to the annuity factor. Now if I ask a question like this, if you deposit 1 rupee today in a savings account, which pay 12% interest per annum, how much will you have in your account in 9 years? Yes? In 9 years, 2.47 rupees. If you deposit 1 rupee at the end of each year for 9 years, in an account which pays 12% interest per annum, how much would you have at the end of 9 years? Yes? You will have 14 rupees and 70 cents. Here, if you deposit 1 rupee at the end of each year, single cash flow can other that is single. You have only one cash flow. But in case of the annuities, you deposit end of each year 1 rupee. So that is the difference. So you better to understand that difference also between the single cash flow and the annuities. Are you okay? Huh? Any queries? Any question? Right. Before going to the present value of the ordinary annuity, I will explain the due future value of the due annuity also simultaneously, right? That is easy. Right. So here I am drawing two timelines. Zero, 1, 2, 3, 4. Here 1000, thousand, 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 thousand. So which one is the ordinary one? Which one is the due one? Suppose this is A, B. This is an annuity. Which is the ordinary type annuity? Which one is the due type annuity? By looking at the timeline, now you should be able to identify that. You know what is the ordinary and due. Which is the ordinary? A. So that B is the due, because you know that 1000 cash flow occurred beginning of the period. Right. Suppose interest rate is 10% per annum. 10% per annum. So I am asking you to calculate value of these two ordinary and due type annuities to the end of year 3. We have only 3 cash flows, right? Only 3. So I want to value this ordinary and this due type annuities to the end of year 3 to here. This one also to the end of year 3. Can you calculate it, please? So just forget about that early formula, annuity formula. Suppose you have not discussed the annuity yet. So if I ask you to calculate this cash flow's future value or the future equivalent value to the end of year 3, what you are going to do? Layman's way. So you are compounding each cash flows to the end of year 3. अभी annuity formula का मतलब करूँ? जब आप किए ना मेरे value कराना तो मेरे और उतना आसान. इधर वाला दाने ये तमाम compound. So what you can do, you may compound each to the end of year 3. So this is end of year 3. This 1000 you can take as it is. This is you have to compound for 1 year. This is you have to compound for 2 years. Here, this is beginning of year 3. So you have to compound for 1 time, compound for 2 times, compound for 3 times. So likewise you can do. So this is 1000. You are compounding only 1 time. So 1.1. This is 1000 end of year 1. Compounding for 1.1 into the power 2. Here, beginning of year 3. So in order to get the end of year value, you have to compound for 1. This is 1000, 1.1 for 2 times. This is beginning of year 1, 1.1, 3 times. So you calculate the value. So what are the values coming here? 1,000, 3,000, 380. Here, 641. So now, if you look at these two, here the 1,000 occurred as a ordinary type annuity. Here the 1,000 occurred as a due type annuity. Now, if you look at this 1,000 here, first one in the ordinary case, this is occurred end of year 1. This is ordinary. So, in order to calculate it equivalent value to the end of year 3, you are compounding it for 2 years. Same 1,000 if it is occurred as a due beginning of the period, in order to get the future equivalent value to the end of year 3, you are compounding how many times? 3 times. And also if you take this one, in the due, this is occurred end of year 2. This is end of year 2. In order to get the future equivalent value to the end of year 3, this one, this 1,000, you are compounding only one time. Same 1,000 when it is occurred as a beginning year cash flow, due. So in order to get the third year equivalent value of this 1,000, you are compounding 2 times. If you take the last 1,000, here it is occurred beginning of year 3. In order to get the third year equivalent, end of third year equivalent value, it is you are compounding 1 time. Same 1,000 when it is occurred as an ordinary annuity, it is occurred at the end of year 3, no need to compound. So if you look at these two, what you can see, in case of the due annuity, in case of that cash flows occurred as annuity due, all the cash flows you have to compound 1 time more. Right? All the cash flows you can see they are compounding 1 year, 1 time more. එකපාරක් වැඩිපුර compound වෙනවා. Ordinary එකට වඩා. You can see that මේක දෙපාරක් compound වෙනකොට this is 3 times. මෙතන මේක එකපාරක් compound වෙනකොට this 1,000 2 times. Last one here no compound, but it is compounding 1 year. So likewise, in case of the annuity due, all the cash flows you have to compound 1 times more. Because of that reason, in case of the annuity due, what you have to do, you can take normal ordinary annuity factor. This is the normal ordinary annuity factor. You can get this from the table also. This normal ordinary annuity factor you have to adjust. You have to convert it to the due annuity. How? You have to multiply normal ordinary annuity factor by 1 plus r. That's all. Why we multiply the normal ordinary annuity factor by the 1 plus r? Because in case of the annuity due, all the cash flows should be compounded 1 time more. වැඩිපුර එකපාරක් සංයුක්ත කරන වෙන්න ඕන compound වෙන්න ඕන. එතකොට ordinary annuity factor එක අඩුවෙන් තමයි compounding වෙලා තියෙන්නේ. If you take the table structure, ඒක අඩුවෙන් compound වෙලා තියෙන්නේ. So in order to adjust that, you have to multiply ordinary annuity factor by 1 plus r. That's all. Now if you apply the formula also here, you can see this relationship. If you apply the formula, future value of this annuity end of year 3 is equal, this is ordinary 1,000 into 1.1 into the power 3 minus 1 divided by 10%. So you will get same answer. If you apply the due annuity formula here, future value of annuity due is equal 1,000 is the cash flow into 1 minus 1.1 into the power 3 divided by 0.1. This ordinary annuity factor you have to avail. You have to adjust for the due case by multiplying 1 plus r. 1 plus r means here 1 10. So that is 1.1. So you will get the same marks. Check whether you are getting using the formula also. I hope you will get the same marks. No? This is the future value of annuity due. And let's say minus let's say. Right. This is the future value of annuity. Now I am asking a question. You get this? Now, here you deposit only 1,000, 3 years. In the ordinary case also, as well as in the due case also 1,000 for 3 years. If you deposit end of the year, at the end of year 3, you are getting 3,300. Same 1,000 if you deposit beginning of the period, you will get 3,641. What is the reason for this difference? Any question? What is it? Yes. 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 Aditya, have you given? You are a formula to use it. I know. Madhya Deva. Yes, sir. This is present. Or you are better with the yes, sir. This one correct. This is correct. So this should be changed 1 plus r in this is annuity this one. Sorry. This should be 1 plus r, that is 1.1 into the power n, into 3 minus 1 divided by 0.1. This is also 1.1, 3 minus 1 divided by 0.1 multiplied by 1.1. Okay. Make a partial over this is a mistake of writing. This is present value. And you also get the same experience. This is present value of annuity formula. Okay, my question is now here you deposit 1,000. Here ordinary case also 1,000 for 3 years. In the due case also cash flow is 1,000 for 3 years. But the difference is here you deposit beginning of the period. This is end of the period. So you are getting some difference. Future at the end of year 3, here you are getting 3,310. In this case, 3,641. My question is why? What is the reason for that? Mathematical reason is clear because here we multiply this answer by the 1.1, 1 plus r. So therefore you will get the higher value. That is mathematical reason. What is the theoretical reason? What is the theory behind this? What is the theory? Theory is time value of money. In this case, suppose if it is a cash inflow, so you are getting cash flow here, beginning of the period. You are getting early. So therefore, what is our theory? Time value of money, money receiving today, more valuable than money receiving tomorrow. So in this case, you are getting money beginning of the period. If it is a receiving, but also if it is deposit, you are depositing early. So therefore, its time value or the value is high. So that is reflecting with the high or the large compounded value. Theoretical reason what I want to show you is the time value of money. Mathematically that is correct because we are multiplying it by 1.1, 1 plus r. But theory behind this is the time value of money. In this case, if it is a due time annuity, you are getting cash flows immediately, beginning of the period. So therefore, that is that you are getting early. So therefore, that time value of money theory says that money receiving today more valuable than money receiving tomorrow. So that is reflecting here. ඒක තමයි මෙතන රිෆ්ලෙක්ට් වෙන්නේ. මෙතනදී cash flows කලින් හම් වෙනවා. ඒ හින්දා ඒකේ වටිනාකම වැඩි වෙනවා. මේකට වටිනවා. So that is the theory. Right. Now you can see example given here. Assume you deposit that same example. Earlier 40,000 end of the period. Earlier that example under the future value of ordinary annuity. Here 40,000 at the beginning of year. Now in the question it is mentioning clearly beginning of the year, beginning of the period. In account which pay 12% per annum. How much will you have at the end of 20 years? Then after 20 years sort of make a compound කරගෙන යන්න බෑනේ value. So you have to apply future value interest factor and so you have to apply formula. So this is the formula because this is beginning of year. So therefore you have to take normal ordinary annuity factor. So this is you have to multiply by 1 plus r because this is the annuity due. Beginning of the period due annuity. So then you can apply these numbers. This is 40,000, 12% per annum. Annually. So then 1 plus r means 1.112 into the power 20 minus 1 divided by 12 into 1.12. So you will get plus 3.2 million 27,949. Same 40,000 if you deposit this one. If you deposit end of the period here, this one, you will get 2.8 million. Okay? If you deposit end of the period at the end of 20 years, you will get 2.8 million 82,097. If you deposit 40,000 beginning of the period here, 3.2. You can see the impact. So you get more than difference is how much? 2 million, 3 million. So that is the amount if you deposit beginning of the period. So significant impact is there because of this time value of money. You can take the answer, you can do this because you should practice of doing that. No, this is the answer. directly you will get this number. No? So now we are going to the next one, present value of the ordinary annuity. So you know now the concept and the things. I can go with this one also. This is present value of the ordinary annuity. So you know what is the ordinary annuity. Now suppose you deposit 25,000 at the end of every year for 15 years. In a savings account that way 12% per annum. So this is a annuity, ordinary annuity, because you deposit 25,000 end of every year. Okay? At the end of every year. So therefore this is ordinary. So what is the balance? What is the present value of this deposit? If you are planning to deposit 25,000 for 20 years, 15 years, in an account that way 12% interest, so you want to value this investment today. Then make a secret valuation already applied at a model. So you want to value this investment to the present. Value of this investment to the 0 or to present. So then what you have to do? Discount total, but that is not manageable. It's not possible. So therefore, we apply this our last time value table, that is present value interest factor annuity table. So in case of the present value ordinary annuity, so you can apply this formula, present value of annuity, normal ordinary annuity is equal, again cash flow into present value interest factor annuity. Present value interest factor annuity you can calculate using this formula, 1 minus 1 plus r into the power minus n divided by r. 1 over 1 plus r into the power n, 1 minus 1 over 1 plus r into the power n. You can rewrite like this way also. 1 minus 1 plus r into the power minus n. Make calculating එකපාරම ගහන්න පුළුවන්. අරක 1 over 1 plus r කියනකොට චුට්ටක් දෙපාරකට කඩන්න වෙනවා. Normal scientific calculators. But if you have a financial calculator, you can enter the formula even. But if you, I think it's easy, 1 minus 1 plus r into the power minus n. Minus, right? 1 over 1 plus r, or you can use this formula. Divide by rate, r. So this part of this formula we call as the present value interest factor annuity. Present value interest factor annuity. This is the last time value table. Present value interest factor annuity. So you can apply the formula because we cannot discount each cash flow separately. So we apply the formula. Present value of this annuity is equal. Deposit 25,000. So this is the cash flow into 1 minus 12% is the rate. So 1.112 into the power minus 15 divided by 12. 0.12, 1 2 or 12%. What is the factor coming here? Present value interest factor. Once you solve this one, you will get the present value interest factor. 1.112 into the power minus 15 minus this divided by 12. So it is 6.81. Present value interest factor here, you will get 6.81. 6.81, you can check, right? Into 25,000. 6.81. Present value interest factor by solving this 1 minus 1.112 minus 0.3 power divided by 12. That is 6.81. Right. So then you will get the answer. Present value of this investment is 170,271. Did you get it? Right. So now I will show you our last time value table. This one. This is future value annuity. Present value single cash flow. Present value annuity. This is the applicable table. So in our example here, rate is 12%. Rate is 12%. So the column here, you have to go to the 12% column up to 15 years. So 15 years means this 6.81. So you can see our present value interest factor here 6.81. So from the table also you can get it. Okay. Now we will go to the next point. This one also better to know with that. Again, in the annuity factor and the single factor, so you can see that relationship. Like in the future value annuity factor, here also you can see table factors are there. Last two columns, if you look at, this is present value interest factor for single cash flow. This is for the annuity. So you can see that relationship. Always annuity factors are, you can construct by taking the cumulative number of these single factors. So if you look at this 5.32, this is the annuity factor at 12% for 9 years. 5.32. සියයට 12 අවුරුදු 9කට අදාළ මේ present value annuity factor එක. ඒතර මේක අපිට මේ formula එකෙන් ගන්නත් පුළුවන්. You can apply the formula or you can use the table. The annuity factor is you can construct by taking the total of the single factors accumulation. So if you look at here, method එක මේකේ total කරොත් මේ ටික එකතු කරගත්තොත් this is equal to 5.32. That is the relationship. Now if I ask question, what is the present value of the 1 rupee if you are receiving in 8 years and also if your cost of fund is 12%? What is the present value of 1 rupee receiving in 8 years? If your cost of fund or the cost of capital, if your required rate of return is 12%. 40 cents. Yeah, 40 cents. Its present value is 40 cents. What is the present value if you deposit 1 rupee for 8 years in an account which pay 12% interest per annum? It is 4.96. Present value is 4.96. So you can see present value when the time is increasing here in the single cash flow you can see present value is discounted because the process is discounting. Present value is increasing because of that discounting process and also because of the time value of money. In the annuity factor also you can see there is a because you are depositing annually. So that is also increasing like this. Right. Anyway, this is important. There is a relationship between annuity factor and single factor. Normally, accumulation of the single factor is equal to the annuity factor. That is better to remember in mind for your personal financial management planning needs. Right. Now we will discuss present value of the annuity due also. So then that annuity is over. Present value of the annuity due. So what you want to pay on? Right. Like earlier, now suppose these two annuities. You know that A is the ordinary, this is annuity. So 10% take as the your principal rate of return or the interest rate. What is the present value of these two? Calculate the present value of these two investments. Just forget about this formula. Calculate the present value of this ordinary annuity as well as annuity. So discounting, because suppose you are not aware about the formula, so what you can do, you may discount each cash flows present and get the total. So if you discount each cash flows to the present, in this case, this is ordinary. So you may discount this 1000 for 1 year. You may discount this second one for 2 years. This is end of year 3. You may discount for 3 years. So this is 1000, 1.1 into the power 1. This is 1000, 1.1 for 2 times, 1, 2. You may discount back for 2 years. Here end of year 3, discount back for 3 years. Here this is a new annuity. This observed at the beginning of year 1, no need to discount. The 1000 you can take as it is. Because this observed at the beginning of the year 1. Correct. No need to discount. This 1000 is equivalent to the today's value. So therefore no need to discount this 1000, you can take as it is. This occurred beginning of year 2. Beginning of year 2. So you have to discount back it for 1 year. Beginning of year 2 to beginning of year 1. දෙවෙනි අවුරුද්දේ මුල ඉඳන් පළවෙනි අවුරුද්දේ මුලට ගෙන්න එකපාරක් discount කරන්න ඕන. So that is 1000 1.1 by 1 time. This is beginning of year 3. So you have to discount for 2 years because this is beginning of year 3, beginning of year 1, beginning of year 2, beginning of year 1. So likewise. So you can get the values. This is 509. $826. $751. So get the total here. Here 1000. This is you can take as it is 1909. Here 826. So likewise you will get the values. So if you compare these two, what you can see here, this is ordinary. I think these values are correct, no? Avan? Okay, right. If you take this one, this is ordinary annuity. First 1000 occurred, end of year 1. To get the value of this 1000 for the today equivalent value, you have to discount by 1 year. Same 1000 if occurred at the due time or the annuity due. This is occurred beginning of year 1, so you don't need to discount it. You can take that 1000 as it is. If you look at the second 1000 deposit, this occurred end of year 2. In order to get the present equivalent value, you have to discount for 2 years. Here, the second 1000 occurred beginning of year 2. This is beginning of year 2. So, in order to get the today present equivalent value, so you have to discount only 1 year. Here, this last 1000 occurred end of year 3. In order to get the present equivalent value, you have to discount back for 3 years. This is occurred beginning of year 3. So, in order to get the present equivalent value, this is beginning of year 3. So, therefore, you have to discount only the 2 years. So, now what happens in the due case? What has happened in the due case? Okay, due annuity. Ordinary future value ගන්නකොට එකපාරක් වැඩිපුර compound වුණා. In case of the due, when you calculate the present value, in case of the due, so it is discounting one time plus. එකපාරක් අඩුවෙන් discount වෙන්න ඕන ordinary එකට වඩා. Because it is occurred at the beginning of the period. ඒතකොට කලින් හම්බෙනවා. So therefore, in case of the annuity due, cash flow should be discounted one time less. That is, you can observe, you can see here. So therefore, what you have to do, you can see here, this is the formula for the annuity due, present value. You can take normal, ordinary annuity factor, present value annuity factor. So it is discounted more than make a very discount until ordinary normal annuity factor ගත්තොත් වැඩිපුර discount වෙලා මේ ඔක්කොම එකපාරක් වැඩිපුර discount වෙනවා. ඒතර ඒ factor එක හදන්නේ වැඩිපුර discount වෙනවා. ඒතර වැඩිපුර discount වෙච්ච එක අඩු කරගන්න so you multiply this ordinary annuity factor by 1+1. ඒ මෙතන process is discounting. ඒතර වැඩිපුර discount වෙලා කියන්නේ අඩු වෙලානේ තියෙන factor discounting 1/1+1. The factor අඩු වෙලා තියෙනවා. ඒතර අඩු වෙච්ච එක වැඩි කරගන්න so we multiply the normal ordinary annuity factor by 1+1. That is the reason. Different reason. You have to do the same thing. එන්නේ එකම දෙයයි but two different reasons. In short, what you have to remember in mind, in case of the annuity due, what you have to do, take the ordinary annuity factor, multiply it by 1+1. Either the present value or the future value. What are the things there? The මම මේක පැහැදිලි කරේ ඇයි multiply කරන්නේ කියලා. දැන් මෙතනදී අපි multiply කරන්නේ මේක අරක වැඩිපුර discount වෙලා තියෙන ordinary annuity factor. වැඩිපුර discount වෙලා තියෙන factor එක අඩු වෙලා තියෙනවා. ඒතර අඩු වෙච්ච එක වැඩි කරගන්න should be multiplied by 1+1. So, ඔයාලට මතක තියාගන්න තියෙන්නේ if it is a due annuity, when you are calculating future value or present value, you can take the normal ordinary annuity factor, even from the table, multiply it by 1+1. That's all. That's all. You have to do that's all. Okay? So then you apply the formula and see whether you are getting the same answer. Now you can apply the formula. Present value of annuity. Present value of annuity is equal cash flow is 1000 into 1 minus 1.1. N is 3 years divided by R. So this is the ordinary case. If it is due, annuity due, present value of annuity due is equal, cash flow is 1000, N is 3, so 1 minus 1.1 into the power minus 3 divided by R. Make up just කරන්න ඕන due case එකේදී by multiplying it by 1.1. Normal ordinary factor you have to increase. Make the ordinary convert you have to multiply it by 1 plus r. So you will get the same answers. No, I apply the formula and also discounting each separately. Again, I will remind you. Now you can see if cash flows occurred as an ordinary way, so the present value is 240,086. If it is occurred as a due annually, present value is 2,735. So this is higher than the ordinary one. What is the reason? Time value of money. Because in this case you are getting this 1,000 today, earlier, immediately. So then it is valued high. So that impact you can see here. The reason behind is time value of money. Mathematical reason because of multiplied by 1 plus 1. Right. So theory implied with these values. The example is there for you to understand. Assume you deposit 100,000 each at the beginning of every year in an account that paid 12% per annum. So now you can see here beginning of the period. So beginning of the period means it is due annually. So then the formula is this one. So so you should be able to apply that. So this is beginning of every year. So this is the ordinary, not the ordinary. This is due time. So therefore you have to apply this formula. You ask him to calculate present value. If you deposit, what is the present value? So you can apply this formula. This is ordinary one. So you can multiply it by 1 plus r. Okay. So you will get the answer. You can do it, right? This is the answer. 836,577. If you deposit 100,000 for 20 years. You can note it and you can do it later. So simply apply this formula. You will get this one. Right. So the next one is the deferred annuity. You need a break. Break for the continuous for the 11:40. You have to start the quiz. 10 minutes break. 10 minutes. Come quickly. And then syllabus it is 10 minutes. 15 maximum. Kalau pada kata tak baik bisa dengan ibarat kata teknologi bisa. Walau lar ada yang kamelar ada, dengan pada kata mana lo equate it. Come quickly, have some and come. Within 10 minutes. Maitana tutorial gana name hada last week I told you to do up to 9 I think in the tutorial. හැදුවට ප්‍රශ්න තියෙනවා ගමන්න පුළුවන්. හැදුවේ නැත්තම් ප්‍රශ්න නැහැ. මොකද ඔක්කොම මෙතන කරන්න බෑ. I can't cover everything. So I have given some practicing question. So I will try to do some at least this discussion question with you. But anyway, you have to do these questions also. Group diagonally across the line. You are the coordinate. Coordinate is there. Happy to see. After 2 weeks. So okay, but the problem is there. Group number 1 and 2, 5 members are there, but 4 and 5 only 3 members. Can you balance? Then we can say like forward to the but rest level. So then I will show. I will give the topics. But Mahita is group with the 4 members. 5 groups, 4 members. Comment and question and Mamadam ne wala padale for example. What is your name? Give me your number, right? So in any case I want to coordinate something with you, so I will contact you. Is it okay? Group at the one. WhatsApp group है वाले ना. Right. So now we are going to the next one, deferred annuity. So I'll go in quickly because now you know the concept. So when it comes to the deferred annuity, as I mentioned earlier, cash flows occur with some delay. Now you can see example here. An annuity plus cash flow expected to occur 3 years from today. Right? The first year, 3 years from today. First 2 years, no any cash flow, so that is occurred 3 years from today. There are 4 cash flows. After that, there are 4. Annually, you are getting 4 cash flows, with each being 30,000. So at the interest rate of 13% per annum, compounded annually. So then this is a deferred annuity. So if you draw the timeline for this one, it is like this. So this is a deferred annuity. First 2 years, no any cash flow. So after first cash flow occurred in 3 years. So you can see in 3 years from now. At the end of year 3. So now in this case, if you want to calculate present value, so I will explain different methods are there since you have learned the concept now. So you can consider different ways to calculate the present value of this deferred annuity. Now this is the timeline for this deferred annuity. 0, 1, 2, 3, 4, 5, 6. 4, 5, 6. Each 30,000. 30,000. There are 4 cash flows, 30,000. This is a deferred annuity. Now, very easy way is that if I ask you to calculate present value of this annuity, you can assume first 2 years also there is a cash flow. Supposing like this. So if you fill the first 2 years also using the 30,000, so it is a normal ordinary annuity. Right? So assuming like this, so then you value the total 6 years cash flow. From the total, you can calculate the first 2 years separately. So then from the total, deduct this 2, then you will get the value. That is very easy. Right? So supposing there is a 30,000 cash flow, first 2 years also. So now this is a normal ordinary life annuity. Then present value of this deferred annuity is equal plus 2 from the total. So total 30,000 into this is present value of annuity formula. So 1 minus rate here. How much the rate? 40,000. 13%. So 1 minus 1.13 into the power minus 6 divided by 0.13. So this is the present value considering this total. All 6 cash flows. From this you have to deduct present value of this first 2 years cash flow. So that is 30,000 into 1 minus 1.13 into the power minus 2 divided by 13%. That is the answer. From the total value, so first you get the total of this 6 30,000 annuity, considered the normal ordinary type annuity. From the total, you deduct this plus 2 years. You will get the answer. Quickly get the answer. I will show you the other ways also. So this is very easy, not much difficult. You may not confuse even. So if the patterns is like this, then the patterns cannot send the full only. But here different ways. The mathematical I also they can get I so likewise different patterns can be there in the different derivative. But if it is like this, you can do like this. This is present value of annuity formula, right? You can remember present value of annuity formula. I think you remember 1 minus 1 plus r into the power minus 10 divided by r. 1 over 1 plus r also you can take. What is the answer? Is it 69,883? Did you get it? 69,883. So that is the value. 69,883. So this is the one alternative way of doing present calculating the present value for the deferred annuity. If it is a pattern like this, so you can do like this. And also I will show you the other way, considering this as an ordinary annuity. You can see the explanation, considering this as an ordinary annuity, we can find the value of the annuity at the end of year 2, then discounted this to the present. So that is another way. I will show you that one also. Considering, now there is no 30,000 here. Considering this as an ordinary annuity. Now, if you consider this for 30,000 cash flows, we consider this as an ordinary type annuity. You remember ordinary annuity occurred end of the period. So, to understand, if I draw another timeline like this, so if you draw the timeline for this 30,000 for 30,000 cash flows, it is like this to 0, 1, 2, 3, 4. Right? So that 30,000 3, 4, 5, 6 cash flows we consider as the ordinary annuity. That we can understand that we have a timeline like this It's like this, no? 0, 1, 2, 3, 4. Beginning of year 1, beginning of year, sorry, not beginning. End of year 1, end of year 2, end of year 3, end of year 4. Considering ordinary annuity. So considering as the ordinary annuity, value this cash flow to the year 2, end of year 2. In the original deferred annuity timeline, we are at the end of year 2. Right? So considering these cash flows as ordinary annuity, value these cash flows to the end of year 3. Then, so you will get some value here. So that is you have to discount it to the C. That is another way. Right? Ordinary annuity का कितने मेथड का value करेगा? A value एक अभी इस तरह के लिए ना discount करना अब then you will get the same marks. Then आप मेरे को ordinary annuity का कितने value करेगा तो value at year 2. In the original timeline, we are at the end of year 2. So value at the end of year 2 is equal 30,000 into 1 minus 1.30%. Still have 1.13. So here 4. Number of years 4. Equation. Right? So there is the 4 cash flows. So e to the power minus 4 divided by 0.13. This is the present value annuity factor. 30,000 into 1 minus 1.13 e to the power minus 4. I will write this minus 4 divided by 13%. So get the value here. The value here. So in the original timeline, we are at the end of year 2. अभी मेटी को ordinary annuity का कितने साल करा देवनी आप लोग तब सारा value करा ला ये इस तरह नहीं है. That is another way. कि तब हमें पहले दिक्कत considering this as ordinary annuity, we can find the value to the end of year 2. Then make a method तब हम value करा करने. So then you can convert this discounting by 2 years to the present. So what is the value you get here? So you did in this which way? So this is what we did. Earlier, in the previous way, did you get the 68,000? May that answer? How is it? How is it? You are getting the different answer. Next, make it same answer can go. The method of the water and the make the argument because others are the rules. Lewatnya itu internet kan sudah itu jadi waktu aku di sana itu kayak yang mereka ini memang aku ini kan berada di kita sampai kan ya same as I made it same as no okay I can publish it. And later we have done the year with an identity the basis of your present value to get the present value you must discount this we answer by 2 years. Discount the value. You may multiply it by 1.12 you will come minus 2. Here you are getting 83,000. Method is 83,000, 89,000, 230, 34, 234. Right. So this is we are in the end of year 2 in the original timeline. So now in order to get this value to the present, you have to discount this. How many years? 1, 2. You have to discount it back for 2 years. So that means you have to discount this 89,234. You have discounted for 2 years. 1.13 into the power 2. So do you get it the same answer? But I will tell you the previous one. You see this one? No mistake. 30,001 minus 1 plus means 1. I see what it is. 1.13 into the power minus 6. And minus 6 divided by 5.3. Are you together? And then you are getting lost? I think you get the same answer. Fine. So this is the another way. So this is the second method. So I will explain you the other method also. Considering this as the annuity due. This is considering as an ordinary annuity. අපි මෙතන විතරේ මේක ordinary එකක් විදියට කරලා ඉන්නලා මෙතනට value කරලා ඉස්සරහට අරන්. Now considering this as an annuity due. එකක් කෙනෙකුට use කරන්න පුළුවන් but there is a chance to get some what we call mistakes. But anyway I will show you considering this as an annuity due. So you value the cash flow to the end of year 3 and then this value discounted back to the present. So if you consider this as an annuity due, you know what is due annuity? That is occurred beginning of the period. Annuity due. So then if you consider these 4 cash flows as an annuity due, so your timeline is like this look. 0, 1, 2, 3, 4. If it is annuity due, first 30,000, beginning of year 1, beginning of year 2, beginning of year 3, beginning of year 4. So this is the annuity due. So we consider this 30,000 for cash flows as a due annuity. So we value this to the end of year 3. අපි due එකකදී එතකොට අපි ඉන්නේ මෙතන. End of year 3 ඊට පස්සේ ඒ value එක අපි discount කරනවා to the 6. Then if you consider this as an annuity due, so then your value at the end of year 3 අපි original එකේ මෙතන ඉන්නේ. In our original deferred timeline, we are at the end of year 3. So value at year 3 is equal 30,000 into 1 minus 1.13 into the power n is 4, right? Year 1, beginning year 1, year 2, year 3, year 4. So n is 4 divided by r 13%. Now this is the annuity due. So therefore this ordinary annuity factor you have to multiply by 1 plus r. You have to multiply by 1 plus r. I have to make a due of the 30 year value. So therefore this ordinary annuity factor you have to multiply by 1 plus r. So what is the value here? Due එක පටල ගන්න එපා. ඒක හරි timeline එකේ හරි තැනට ඔයාලා ඒක map කරගන්න. ඒක නැතුව තව දිනවලුයි. So if it is a due, so beginning of year 1, then end of 30 year deferred annuity is beginning of year 1. Because that is due time cash flow. Beginning of year 1, year 2, year 3, year 4. So likewise. So I am getting here 3.361. This is 3.361 into 30,000. Oh, into 30,000 means 100, 830. Is it correct? So now you have to discount this value to the present. So here we are in the end of year 3. Method in there. Right? So you have discounted this 1, 2, 3 by 2 times. So then we discount this 100,834, 1.13 into the power 3. So you should get the same answer. I get the same answer. So this is another way, considering as a due. But I am not recommending you to this for the exam because you might if you wrong when you are interpreting this one, so your answer will be different. If they are interpret the due figure, so you get the wrong answer. But anyway, this way also you can consider it as a due and. If it is all these things are difficult, there is another chance. So you can discount each cash flows to the present, considering each separately. Right? So that is the layman's way. You can discount this 30,000 back 3 years. This is back 4 years. This is back 5 years. This is back 6 years, and get the total. Again, you will get the same answer. But that is okay for 3. Now here only 4 cash flows are there. But suppose then if it is 10, not possible. So therefore, that is not advisable. But anyway, in this case, separately, you can discount even. You will get the answer. Right. So this is the valuation of the deferred annuity. So either way you can do that for the exam. So I show you the 4 ways of doing this deferred annuity valuation. Any question? Right. So now we are going to the perpetuity. So that is easy. You know what is perpetuity? Perpetuity is the annuity goes forever. It is annuity with the indefinite period. So in case of the perpetuity, is a infinity number of cash flows are there conceptually. Right? You will get the fixed payment for a long period. So we consider it as a perpetuity type cash flow. In case of the perpetuity, you can see what is happening. Look at here. So this is the our present value of annuity formula. 1 minus 1 upon 1 plus r into the power n divided by r. So in case of this perpetuity type cash flow, this n become very large number. So n goes to the infinity. Right? Conceptually with the perpetuity type annuity, this n is approached to the infinity. So once this n is approached to the infinity, 1 upon 1 plus r n, this part of this formula approach to the zero. In the financial mathematics, we can prove this. Mathematics is a proof when the n is goes to the infinity, so 1 upon 1 plus into the power n, a part is approached to the zero. So ultimately, present value of the perpetuity therefore is equal cash flow divided by R. Periodic payment, PMD means periodic payment or the cash flow. Cash flow divided by R. That's all. If it is a perpetuity type cash flow, if you want to calculate the present value, simply periodic payment divided by discount factor or the interest rate. If this is occurred as beginning of the period cash flow. Now look at these two examples. There is an investment opportunity. Pays 150,000 rupees at the end of each year for an indefinite period. So this is an annuity perpetuity. It goes for an indefinite period. So suppose your required rate of return is 12% per annum. So what is the present value? What is the present value of this investment? So you can apply, you cannot apply annuity formula, present value formula, no, because this is a perpetuity. Simply, you can calculate present value of this perpetuity, 150,000 divided by discount factor. So that is 1 million, 1.2 million, 50,000. If this 150,000 occurred at the beginning of each year, the 150,000. Suppose there is an investment opportunity which pay 150,000 at the beginning. At the beginning of each year for an indefinite period. So then you can calculate present value of this perpetuity, 150,000 divided by discount factor or the interest rate, multiply by 1 plus r. If it is a due type cash flow, if it is occurred at the beginning of the period, so you have to multiply cash flow divided by R. The answer you have to multiply by 1 plus R. So you can see here present value is 1.4 million. So you can see this is greater than this 1,000 to 1 million to because of the time value of money. Because here this 150,000 occurred beginning as a beginning cash flow. So therefore its value is 1.4 million. When it is occurred at the end of each year, value is 1.2 million 50,000. So that is the present value of the perpetuity type cash flow. That is easy. Okay. Any question? Do you have any question? So that is actually the end of time value of money. Now we have certain application. I want to explain the time non-amortization schedule and certain application. Now look at this one. This is all. Conceptually, time value of money is over, but we have certain applications to discuss. Look at this one. If you borrow 5 million at 15% interest rate per annum, compounded monthly, right? For 25 years, in order to buy a house, what will be your monthly installment? For the exam, you will get a question like this. Present value, future value, so you get the applications like this. Right? If you borrow 5 million in an interest rate of fixed interest rate 15% to be prepaid in 25 years with the monthly installment. Appear the sample type she's there. Commercial. What is the monthly installment? So now suppose your customer has come and asked 5 million. So you told that the interest rate is 15%. You can go with the fixed interest rate for 25 years. So you have to calculate the monthly installment and you have to so calculate it. What is the monthly installment? Now you can do because now we have discussed everything. So you can apply the things you learned to this application. So what is the how much the monthly installment? And also part 2, what will be the loan outstanding balance at the end of 4 years? Suppose the customer has paid 4 years continuously without any default. So now customer wants to know what is the outstanding balance of your loan. He is going to settle the loan. So you have to tell this is the outstanding loan balance. So how much is? So you will be able to calculate. Right, do quickly. So then we can go to the amortization schedule also. What is the application here? What is the application here? Now we have learned everything. So what is the application here? What is the formula? Next. What is the application? Have you calculated what is called? Shall we ask our commercial background? Officer, how can I explain the way of calculating the monthly income? Like master ready, nakala man tax करना पड़ा. मगे मासे के वाले किया के बाद लोड होती ना ना Fixed interest rate taking your floating limit fix. Floating discuss करना है floating लो देखकर बिना मेथड का भी टाइम टाइम खाना लो. But here we discuss only the fundamentals, so we can assume that 50% remain constant. Yeah, load stand for the actual fixed rate solution. So look at the application. What is the application? Anyone? Yes, please. How you calculate? Compound? No, tell me, because now we are applying the things we learn. Then we conceptually present value, future value, senior cash flow, deferred annuity. So now we are applying to the practical scenarios. Yes. Just tell me, don't worry, because you are coming here for learning, no? No worries. Anyone, please? Otherwise, you are taking time. Go ahead. If I just have to show the way of calculating. Now, if you draw the timeline for this example, just draw a timeline. So it is like this. No? Today you are going to bank to borrow 5 million. So you are going to repay this loan in 25 years with a monthly installment. It goes to the 25 years. So 25 years monthly installment means how much? 25 to 12. Yes, sir. 25 to 12. 300. Eh? 300. So using 300 installments, you are going to settle this loan using monthly 300 installments. So you are going to borrow 5 million today. So bank says the interest rate is 15%. So what is you are doing after you are taking this loan? At the end of each month, you deposit your installment for 300 months. So what is you required to calculate? Your monthly deposit. How much the monthly deposit? What is the application? This 5 million is equal to what? This monthly installment is what? Then we have a මාසයක් අවසානයේ අපි හිතමු amount එක x. ඒක අපි දන්නේ නැහැ ඒක තමයි හොයන්න බෑ. This monthly installment is what? It is an annuity. අපි හැමදාම මාසයකට මේ ගාන බැංකුවට දානවා. So this 5 million is equal to what? Present value of this annuity. So then what is the application? Present value of annuity. So you have to apply present value of annuity formula. So this 5 million is the present value of annuity. ඔයා මාසිකව මාස 300ක් ගෙවන monthly වාරිකවල අද වටිනාකම තමයි 5 million. It is your loan. You are borrowing 5 million. එතකොට R 15% time 300 months monthly. So now you have to work out the cash flow. You can do it. Nothing difficult because you know the formula, you know the way of calculating. So solve this for the periodic payment. Cash flow, monthly installment. So our formula is present value of annuity is equal periodic payment or the cash flow monthly installment. We don't know PNT into. So this is present value of annuity formula. So 1 minus 1 plus R into the power minus n divided by R. Since we are paying installment monthly, so therefore cash flow frequency is 12. So therefore we have to use more frequent compounding. So we have to adjust this formula how R divided by M, N multiplied by M, R divided by M. Because cash flow frequency is 12, so therefore compounding frequency also should 12. That's all. So solve this. So 5 million is equal periodic payment එක තමයි මේ හොයන්න යන්නේ into 15% කරා හැමදාම කම්පියුටර් එකේ දෙකදසම 0.0125 125 into the power minus 100 300 divided by 0.0125. Oleh kuis ke time में कौन आने? जहाँ है पास हमारा टाइम भी है जहाँ है हाथ बड़ा काम हो रहा है. स्टार्ट में महिला स्टार्ट करना 20 मिनट्स देंगे मटर में एक्सेस होता है मैं डिस्कस करा मैं 20 मिनट्स डाला भी होता है तो अनडिमांड सब नहीं है 5 मिनट के दर में थोड़ा दिन 10 दिन तक बहुत है हमें 5 के बिना डिस्कस के डाल अब वेट करना चल रहा है थोड़ा निकल के इकट्ठे दिए आता एक बोला दो और बात करें ना और के दिया यार अभी इक्वेटर पर एडेंजर माइनस 20 मिनट्स दे रही है तब यहां से ये देखिए माने कितने आई हैव नो आईडिया अबाउट दैट वीडियो राइट सो व्हाट इज द आंसर हियर here then what is the monthly installment 64,041 64,041 64,000 Maybe access to the see all this happening. Shall we attend the quiz quickly? A very simple quiz based on the introduction and thing. Other part I will explain later. So you can attend this one in the home also. But anyway, shall we do the quiz because I want otherwise I can't cover the 4 quizzes within this period. And we go to elements and see what is the situation. Show me. Attempt after, but attempt after 20 minutes, spend another attempt after. We say that. Count down and only 20 minutes. Okay, may practical just may password मत elaborate करना attempt के count करोगे अब anyway I will ignore that one may अब जब ये क्या Anyway, I will share this the questions. You can see this question and you can try out them with long given marks. For the next time, I will give you the three questions, three or four questions, descriptive type question based on the timeline of money. So you have to attempt during the class time. You have to give the answers to me. I will give the marks. Right? That way, I will cover one quiz, not the multiple quizzes. Yes, next week you will have a classroom test. It can be multiple test limit, not the multiple. So you have to do like this. You will mark them within the class and you will get some marks. Next question later, quiz se I will share with you. Then you can do it. Right, right. So did you get the 64,041? Right. So this is your monthly installment. This is your monthly installment. Right? So monthly you will deposit 64,041 for 300 months. So then your loan will be over. Next part it asks what will be the loan balance outstanding at the end of 4 years. Now suppose you deposit up to 4 years. Up to 4 years continuously you are paying this 64,041. So up to 4 years means how many installment? Consistently you are paying 4 years this loan installment. 4 years means 12 into 4, 48 400. 4 years 4 years into monthly 48. Oh. So after 48 installment, now you have paid. You have deposit in the bank. So now you are going to settle the loan at the end of 4 years. Right? So continuously you have paid the monthly installment for 4 years. Then after monthly installment can calculate that is 64,041. You know හැමදාම මාසිකව ඒ ගන්න අවුරුදු 4ක් ගෙවලා. That is 48 installment. So now you are going to bank and you are asking if you are going to settle the loan, how much should I have to pay? What is your outstanding loan balance? Yes? How to calculate? දැන් කස්ටමර් කියනවා මම අවුරුදු 4ක් ලෝන් එක ගෙවුවා මම දැන් මගේ සල්ලි හම්බෙලා තියෙනවා මම සෙටල් කරනවා ලෝන් එක. මම කීයක් ගෙවන්න ඕනද තාම? So what is the balance of your loan? You have borrowed 5 million. Your monthly installment is 64,041. අවුරුදු 15කින් 25කින් ගෙවනවා නම් මාසෙකට ඔයා මෙච්චරක් ගෙවන්න ඕන. 64,041. ඒකට දැන් ඔයා හතරක් ගෙවලා. So you want to settle it. So how much you have to pay the settlement in the loan? Okay. You have some idea. Tell me. Yes. Future value. So you mean that future value is at the end of 25 years. Or can you make 300 future value? 64,041 or is value. You must say outside the එයා ගෙවලා තියෙන්නේ අවුරුදු 4ක්. ඉතින් ටයිම් එකේ අපි ටයිම් එකේ ආවි in the same point. මේ මෙතන ඉඳගෙන so you are valuing here. එතනට value කරනවා. to the 25 years end. ඉතින් මෙතනට එකක් ගෙවුම් ටිකක් කරනවා. Are there any equivalent time? There is a problem. මොකක්ද කරන්නේ? What you have to do? Now, how many installments remains to be paid? Now you have paid 48. How much is the fee given? How many installments remains to be paid? From the 348 paid. So remains 252. You have to pay more 252. So what is the loan outstanding balance? What? මේ ගෙවන්න තියෙන installments වල මෙතනට value. That is the loan outstanding balance. With the loan amortization schedule also, I will show you the outstanding balance calculated. Now you have to pay 252 installments. You know that normally interest are calculated on the reducing balance. If interest calculate 5 billion not calculate 48 given percent 5 billion not interest so that is we are calculating on the reducing balance. That is happening in this process. I will show you in the loan amortization schedule. So loan outstanding balance at the end of 48 installment paid is you have to pay 252 installments more. Present value of this 252 installments. So value the loan to here. Value at the 48 month is equal. Your monthly installment is 64,041 into 1 minus 1 point, not the 1.14, 1.0. This is monthly. 15% divided by 12, 0.025. Yeah? 1.0125 into the power minus 252. Now this is value divide by 0.0125. So this is the outstanding balance. If you are going to settle the loan, this value you have to pay to the bank. You have to pay 4.8 million 99,448. After 4 years of payment. So this is the loan outstanding balance. Then backport again, then what customer come I know another thing that go on that is very easy. So that banks are using time value papers. They are calculating based on these factors. So you have to pay 4.8 million. Then you have to remember and come with check you are no make them on the put it equal as okay. But your information is not for that you know that. So otherwise this is the outstanding value 4.8 million. May I take another 10 minutes to complete the non-amortization schedule? Huh? If I have no problem. Huh? I think you have a lecture at 12 o'clock. You want to have a lunch, I know that. If I okay. Anyway, so I will explain the amortization schedule and you will see in the next week. Then we are starting, I think, segregate evaluation. After this, segregate evaluation and the risk handler. So next week we will have a classroom test. But anyway, then what I can tell you about this. ඒ කුසිය මගේ next week එකට දාන්න. ඔය මේ time එක කරන්න දැන් මේ guarantee වල මම guarantee එකක් හදන්න ඕන ඔයාලට ප්‍රශ්න ටිකක් දෙන්න. Otherwise no effective. ඒකින්ද but anyway you may ready because I am finishing this one. I will discuss some discussion question with you. After that I will give you 2-3 questions to do yourself. I will mark you. මොකද ඔයාලා නැත්තම් paper එකට ලියනකොට අන්තිමට මම දකින්නේ paper එකට ලියනකොට තමයි ලියලා දෙන්නේ. එතකොට ඉතින් coach ගිහිල්ලා ඉවරයි මට කොහොමද ලකුණු දෙන්න වෙනවා. So therefore I will give you may come up with some blank sheet. ඒක එකක් කරගෙන දෙකක් ඇතුලේ. So then I will collect them and we will discuss and I will do some marks. So ඔයාලගේ මේ quiz එක next week එකේ ලියන්න. Right? දැන් ඒක කරන්න බැහැ කාටද? Okay, I will finish. Any question? Any clarification? Do you have any question? Right. Okay, then I will stop. We will continue from this one next week.